Tēnā koutou katoa, it's Mrs. Goodson here, and this is the third video about periodic trends for chemistry 3.4. This video is about electronegativity. So what is electronegativity? So the definition is a measure of the attraction between a nucleus and a bonded pair of electrons. Note that it is the valence electrons or the outer electrons that are the bonding electrons. So what affects electronegativity? So this attraction between the nucleus and a bonded pair of electrons is affected by, firstly, the nuclear charge. So if an atom has a larger atomic number, that means it's got more protons and it will have a stronger nuclear charge. It will also be affected by the atomic radius. That's the distance between the nucleus and the bonded electrons. So the bigger the radius, the smaller the electronegativity, because there will be less attraction between the nucleus and the bonded pair of electrons. Also, which affects the electronegativity is the shielding effect of the inner electrons. That's between the nucleus and the bonded pair of electrons. Okay, so what is the trend? Across a period or a row, electronegativity increases. Down a group or a column, electronegativity decreases. So this table shows relative electronegativities of the elements. Note that group 18 is not included as they do not usually form bonds. So the most electronegative atom is fluorine. Now these numbers are just relative to the strength of fluorine. They don't have any units. So you can see that oxygen, nitrogen, and chlorine all have similar electronegativities because they're pretty close to fluorine. So you just need to remember the trends. It increases across a row and decreases down a column. So down a group or a column, for example, as you go from lithium to sodium to potassium, electronegativity decreases. This is because the bonded electrons are in an energy level further from the nucleus, with increased shielding from inner shells. This is despite there being more protons and therefore an increase in nuclear charge. As you go across a period or a row, for example, from beryllium to boron to carbon, electronegativity increases. The bonded electrons are in the same energy level, but there is an increased positive charge on the nucleus because there are more protons. So the attraction between the nucleus and the bonded electrons is the same. And so that, it increases as there's more protons. Okay, here is an example question. Fluorine is more electronegative than chlorine. Why? So the first thing to establish is that chlorine is below fluorine on the periodic table. Chlorine has an atomic number of 17, so has 17 protons, compared with fluorine, which has 9. So there is an increased nuclear charge. However, the bonded electrons are in an energy level further away from the nucleus, so there is increased shielding from the inner electrons. And therefore, as you move down a group, the electronegativity of an atom decreases. So the first step when answering one of these questions is to write down for each atom how many protons it has, how many electrons, and write the electron configuration. Then you can easily see that chlorine has more protons and that it has electrons in another shield. Okay, what does shielding mean? Now, chlorine has more electron shells, so it has more inner electrons, and therefore that has stronger electron-electron repulsions, which reduces the attraction between the nucleus and the outside electrons. And these outside ones are going to be the bonding electrons. So that is why fluorine is more electronegative than chlorine because the outer electrons are closer to the nucleus, and so there's less shielding, even though chlorine will have stronger nuclear charge. Okay, let's look at an example comparing across a period. Oxygen is more electronegative than nitrogen. Why? Okay, so you can see from the diagrams that they have electrons in the same shells. The valence electrons are in the same shells. Nitrogen has 7 protons and oxygen has 8 protons. So because oxygen has more protons, there is a stronger attraction between the nucleus and the bonded electrons. So therefore, as you move across a period or row, the electronegativity of an atom increases. In this table, there is a summary of the periodic trends, the 3 trends you need to know for level 3 chemistry. There's atomic radius, ionization energy, and electronegativity. So as you go across a period, otherwise known as a row, the atomic radius decreases, the ionization increases, and the electronegativity increases. However, as you go down a group or a column, the atomic radius increases, the ionization decreases, and the electronegativity decreases. So for achieved, you need to be able to state these trends. For merit and excellence, you need to be able to explain giving reasons. And for excellence, you need to be able to explain the links between the trends and giving reasons. And this brings us to the end of the 3 videos about periodic trends.